All right, so today we are now on chapter 3.5, which is on Newton's third law. So what does Newton's third law state? Newton's third law states that for every action force, there is an equal and opposite reaction force. Couple of key words here, okay? Equal and opposite, okay? That means the same, but the opposite part means they're acting on different objects. Okay, so we've got a jet here. Okay, and that jet comes in. So it's moving. There's got to be some unbalanced forces coming on. So let's look and see what's going on with this jet. So the jet burns its fuel and it pushes its fuel out. There's your action. Okay, the reaction with the same amount of force, okay, that fuel, okay, your gases expanding everything, push on the jet. So the jet moves. But the key here is that this reaction force, okay, these two forces, the action and reaction, are equal to each other. Act on different objects, but the size of them is the same. So for instance, if this one was 50 newtons, this one is also 50 newtons. So if we know the force, if we know the mass of this plane, we can tell the acceleration. So what happens on a trampoline? Okay, this person is up in the air. Gravity is going to push him down towards the ground. He is going to land on the trampoline. That trampoline has that elasticity. It's going to expand. He is going to be pushing on the trampoline. Say, an example again of 50 newtons. So what's the trampoline going to push back on him with? If you said that the trampoline is going to push back with 50 newtons, you are correct. Now, the guy is going to go flying into the air. Force equals mass times acceleration. Okay, however, he's applying 50 newtons of force to the trampoline, but the trampoline isn't moving. It's not sinking into the ground. Remember, to have acceleration, we have to have unbalanced forces. And remember, the ground is also applying a force on that trampoline, okay, which counterbalances that. So the only unbalanced force is applied to the guy. Okay, so the action and reaction forces act on different objects. Therefore, they are not balanced forces. Okay, they're equal forces, but not balanced. There's balanced forces acting on the trampoline, but the guy jumping has unbalanced forces. So let's look at a couple of situations. I hired some highly paid actors to help me with these videos, so expect great acting skills here. All right, situation one. Macy and Mr. Falkavage are pushing on each other. Both are pushing. Let's get a new number here. With a force of 100 newtons. Okay, equal but opposite. Now, the response to the forces are very different. The force Macy applies on Mr. Falk does not move him. Okay, he does not move. There is no response to that force because he still has other forces acting on him, and the force that Macy applied does not cause him to move. However, the 100 newtons of force that Macy has applied to her by Mr. Falkavage causes her to move backwards. Okay, there's less friction for her to overcome. She's in a rolly chair. So that 100 newtons was able to move her. Let's look at another scenario. Okay, scenario 2. Okay, now Mr. Falk and Declan are sitting in a rolling chair and Macy is in a rolling chair. And they are both again going to push each other. And let's see what happens. Okay, I want you guys to make a prediction. Is Macy going to move? Is Mr. Falk and Declan going to move? Or are they both going to move? All right, situation 2. Let's look and see what happened. Okay. For consistency's sake, let's just say both of them applied 100 newtons of force. Both are in a rolly chair, but the 100 newtons of force was not enough to make Mr. Falk and Declan move. It was, however, enough again to propel Macy backwards. All right, hopefully we're starting to figure out what happens. Let's look at situation 3. Now we have Macy and Declan in the chairs. Prediction needs to be made. Who is going to move, Macy or Declan? All right, situation 3, what happened? Okay, now the forces probably applied are closer to 50 newtons. We both agree they're applying less force. Okay, however, Macy's in a rolling chair, but that 50 newtons of force was not enough to really get her to move. However, the 50 newtons of force on Declan with a smaller mass was enough to have him accelerate backwards. Hopefully you can now see how these action and reaction forces are working. Okay. When you're done, please get ready for lab tomorrow. It's going to be very important that you know the steps because I'm going to give you very little directions. And if you have any questions, please make sure to ask them.